Alright, in this lesson we're going to be looking at complementary angles. You should remember from Year 7 mathematics that complementary angles, they're angles that add to 90 degrees. That's basically what they are. Two angles that add to 90 degrees. Now, with trigonometry, at the moment we're just dealing purely with right angle triangles. So one of these angles in our triangle is 90 degrees. And because the angle sum of a whole triangle is 180 degrees, then that must mean if I call, say, this angle down in this corner here, we'll call that theta, then that must mean this angle up in the other corner, the remaining corner, it's got to be 90 minus theta. So these angles are complementary angles. Okay, now what we're going to do is we're going to look at the trig ratios again for a right angled triangle, but now we're going to take into account that we've got theta, our original angle, and its complement, the third angle in the triangle. This time, however, instead of using the terminologies opposite and adjacent and hypotenuse, what I want to do is actually label each of the sides with a letter. And we'll label, let's say this side's going to be A, this side will be B, this side will be C. Okay, now I'm going to find out what the sine, cosine and tangent ratios are for theta, for all three of those. Now if we remember SOHCAHTOA, it means sine theta is going to be the opposite over the hypotenuse, which will be B over C. And if we remember cosine, cosine was adjacent over hypotenuse, so it'll be A over C in this case. And if we remember the tangent ratio for theta, it'll be the opposite over the adjacent. So tan of theta is going to equal B, the opposite, over A, the adjacent. So we have these three ratios, and that's all fairly old hack now for you, I hope. Well, what we're now going to do is consider, well, what happens if I find the trig ratios, all three trig ratios, for the complementary angle? So over here, I'll put right next to it, sine of 90 minus theta. Okay, this time the sine, it's the opposite over the hypotenuse. Well, this time the side that's opposite this angle is A. So sine of 90 minus theta is going to be A over C. A over C. And if we do the same thing for cosine of 90 minus theta, we'll see that cosine of 90 minus theta, it's going to be the adjacent over the hypotenuse. So that'll be B over C. And if we do the tan ratio for 90 minus theta is going to be equal to the opposite over the adjacent, which will be A over B. Okay, and if you look at these carefully, some of you may have already seen that actually a little bit of a pattern arises. You see, what's happened is, if I find the sine of theta, it's B over C, but actually the cosine of 90 minus theta is also B over C. So these two things here are equal. So the sine of theta is equal to B over C, which will equal the cosine of its complementary angle, 90 minus theta, which is also B over C. And if we look at the cosine ratio here, the cosine of theta is A over C, which is equal to the sine of the complement of theta, the sine of 90 minus theta, which is A over C. So these two things, they're also equal. So what we find is the sine of an angle is actually equal to the cosine of its complement. And the only other thing that we might observe also is that in the tangent ratio for theta, we have B over A, but then when we take the tangent ratio for the complement of theta, 90 minus theta, then we get A over B. So what's happened is the ratio has been inverted. Okay, complementary angles, we're going to be using that knowledge in addressing some of the questions that we've got in the text.